In this video, we're going to learn about the law of sines. And if you look at the top of the screen, you're going to see this formula that says the sine of A over little a equals the sine of big B over little b, which is equal to sine of big C over little c. And that's going to make more sense once we actually jump into some problems. So before we take a look at example 1, the law of sines is going to help us solve for missing angles in sides in certain triangles, and we don't have to use this with right triangles. So if you guys have already learned SOHCAHTOA, you may remember that that is only used for right triangles, but the law of sines can be used for any type of triangle as long as we have a certain requirement, which I'll talk about in example 1. So in example 1, it says solve the triangle below. And when a question asks you to solve the triangle, it just means solve for all of the missing angles and sides. So we have to solve for this missing angle C, and then we're going to have to solve for these missing sides. So the only requirement to use the law of sines is that we have one angle and side pair. So if you look, they gave us the measure of angle A, and they gave us the length of the side that's across from angle A, and we're going to label this with a little a. So we typically label angles with uppercase letters, and then the sides across from it we're going to label with the same letter but in lowercase. So let's just go ahead and label the rest of this triangle. So if over here we have angle B, which is big B, across from it we're going to have little b, so side B. And then we have angle C with an uppercase C, so across from it we're going to have a lowercase c for that side. And because they gave us one side and angle pair, right, they gave us angle A and side A, we know we can use law of sines. And if they don't give us that, we're going to have to use something called the law of cosines, which we've also made a video explaining if you guys want to check that out. So let's show you guys how to use the law of sines. So let's solve for side little b first. So we're going to use this proportion that says the sine of angle A over the side A is equal to the sine of angle B over the side B. And now we're just going to plug in what we know. So we know that angle A is 80 degrees. So we're going to say the sine of 80 degrees over, we know side A is 10 inches, so over 10 is equal to the sine of angle B, which is 60 degrees, over little b. And now we have to solve for little b. So I'm going to actually solve for it before I put it into my calculator so that I'm not rounding throughout. So what we're going to do is we're going to cross multiply. So we're going to multiply b by the sine of 80 degrees, set that equal to 10 times the sine of 60 degrees. And now to get the b by itself, and let me put these degree symbols here, we just have to divide both sides by a sine of 80 degrees. So we're going to divide both sides by sine of 80 degrees. And I'll write this up here. We are going to get that little b is equal to 10 times the sine of 60 degrees over the sine of 80 degrees. And now we're just going to put that in our calculators and make sure that your calculators are in degree mode instead of radian mode when you're putting this in, or else your answer is going to be off. And we should get that little b is equal to roughly 8.79 inches. And you just want to mentally check that that makes sense. So because angle B is smaller than angle A, we know that side B should be less than side A, which it is. So at least we know that part of our answer is correct. So now let's find angle C and side C. So to find angle C, we just have to remember that the angles in a triangle add up to 180 degrees. So I'm going to do this over here on the left underneath the triangle. We can say that 60 degrees plus 80 degrees plus angle C has to equal 180 degrees. And we can combine 60 and 80 to get 140 degrees. Plus C is equal to 180 degrees. Subtract 140 degrees from each side to get that angle C is equal to 40 degrees. So I'm going to write that in here. And now we can set up another law of sines proportion to solve for side C. So this time I'm going to say that the sine of angle A over side A is equal to the sine of angle C over side C. And I'm just going to plug in what we know. So we know angle A is 80 degrees, so sine of 80 degrees over our side A, which is 10, equals sine of angle C, and angle C is 40 degrees, over side C. And again, we're going to cross multiply. So we're going to get C times the sine of 80 degrees equals 10 times the sine of 40 degrees. And to get c by itself, we're going to divide both sides of our equation by sine of 80 degrees. And let's put this over here because I'm running out of space. And on the left side, we're left with c, and on the right side, we're left with 10 times the sine of 40 degrees over the sine of 80 degrees. And now we're going to put this in our calculator. And we get c is equal to about 6.53 inches. And side C should be the smallest side in our triangle because angle C is the smallest angle, so at least we know we're probably in the right ballpark. So let's just box our answers. We got that angle C is 40 degrees. We got side B is 8.79 inches. And we got that side C is 6.53 inches. So we found all the missing angles and sides in our triangle. Let's go over another example. So for example 2, they didn't draw a triangle for us. They just told us that in triangle ABC, angle B is 100 degrees, side B is 12 centimeters, and side C is 7 centimeters, and we want to solve for the remaining angles inside. I'm just going to sketch a quick triangle. You don't have to, but I think for geometry it's nice to sketch the shapes. So I know that angle B is 100 degrees, and side B is 12 centimeters. And my triangle probably isn't going to be to scale because I don't know what angle C measures. So I'm just going to put angle C over here and angle A over here. And I know side C is 7 centimeters. So this time, they gave us one angle and two sides. But because we have an angle side pair, right, we have angle B and we have the side across from it. So we have side little b, we can still use law of sines. It's just that we're going to be solving for an angle first this time. So what we're going to do is set up sine of angle B over side B is equal to sine of angle C over side C. And that's because they gave us side C. So we need to solve for angle C before we do anything with angle A and side A. Now we're going to plug in what we know. So angle B is 100 degrees, so we're going to do sine of 100 degrees over side B, which is 12 centimeters, is equal to sine of C over side C, which is 7 centimeters. And this time we're not going to cross multiply because what we're solving for is in the numerator. You can cross multiply, but it'll just add some extra steps. So what we're going to do is multiply both sides of our equation by 7. On the left, we're going to have 7 times the sine of 100 degrees over 12. And on the right, the 7s are going to cancel out and go to 1, so we're going to be left with the sine of angle C. And now we have to remember how to solve for an angle with trig function. So if we have the sine of C, how do we get rid of this sine? To get rid of a sine, we have to do the sine inverse. So what we're going to do is take the sine inverse of both sides. And on the right side, that's going to leave us with C. And on the left side, we're going to have the sine inverse of this entire expression. So of 7 sine 100 degrees over 12. And now up here, we'll write our answer. We're just going to put this in our calculator. And if you do that, you should get roughly 35.06 degrees. And you want to mentally check that angle C should be less than angle B. Because side B is less than side C, we know that angle C should be smaller than angle B. So we know our answer is probably in the ballpark. So I'm going to box that up. We get angle C is equal to 35.06 degrees. And now let's solve for angle A. So let's write 35.06 here. And down here we'll solve for angle A. So we know that angle A plus 100 degrees plus 35.06 degrees has to equal 180 degrees because the sum of the angles in a triangle is always 180 degrees. We're going to add 100 plus 35.06 to get A plus 135.06 degrees equals 180 degrees. And then we want to subtract 135.06 from both sides to get that A has a measure of 44.94 degrees. And now that we have angle A, we can solve for side A by using the law of sines again. So let's say that the sine of angle B over B is equal to the sine of angle A over A. You could also say the sine of angle C over side C is equal to the sine of angle A over side A. It doesn't actually matter which angle side pair you use. But I just use the ones they give us in case I made a mistake when I was solving for my big C. So if I made a mistake when I'm solving for big C, then it's going to mess up my side A if I use that in my proportion. So again, I just use whatever values they gave me initially when I'm solving for my missing sides and angles. So let's plug in what we know. Angle B is 100 degrees. We're going to say sine of 100 over side B, which is 12, is equal to sine of angle A. Angle A is 44.94 over side A, which is what we're solving for. And now I'm going to cross multiply for this one because we're solving for what's in the denominator. So I'm going to have A times the sine of 100 degrees is equal to 12 times the sine of 44.94 degrees. To get the A by itself, I'm going to divide both sides of my equation by sine of 100 degrees. And up here, I will continue this. So on the left side, we're just left with little a. On the right side, we have 12 times the sine of 44.94 degrees, all over the sine of 100 degrees. And when I put in my calculator, I get roughly 8.61 centimeters for side A. And now we're going to go over one more example, and this one's actually very important to watch. So I encourage you guys to watch this last example, even if you understand the first two examples we went through, because it is a special case that happens when we're dealing with law of sines, where we're actually going to have to solve two triangles using the information they gave us. So this last example tells us we have triangle ABC. They told us angle C is 15 degrees, side C is 8 feet, and side B is 20 feet. And we want to solve for the remaining angles and sides. And I told you guys this example is going to be a little bit different. So what we're going to do is sketch a triangle. So let's just sketch something like this. I know angle C is 15 degrees, side C is 8 feet. And I know side B, which I'll put down here, is 20 feet. So I'll put C equals. So this is going to be angle B up here and angle A over here. And let's solve for angle B by using the law of sines. So we're going to say that the sine of angle C over side C is equal to the sine of angle B over side B. We're going to plug in what we know. So we know angle C is 15 degrees and side C is 8 feet. Set this equal to the sine of B over side B, which is 20 feet. To get the sine of B by itself, we're going to multiply both sides by 20. On the left, we're going to have 20 times the sine of 15 degrees over 8. And on the right, the 20s cancel out and go to 1, so we're left with the sine of B. And then remember to solve for the angle. If we have the sine of some angle equals something, is we're going to take the sine inverse of both sides. So on the right, the sine and the sine inverse cancel out. And on the left, we have the sine inverse of this entire expression. And now we're just going to put this in our calculator, and I'll write the answer over here. So go ahead and put this in your calculator. And we should get that angle B is roughly 40.32 degrees. And now we have to talk about what's called the ambiguous case when we're dealing with law of sines. So because side B is bigger than side C, right? Side B is 20 feet and side C is 8 feet. We know that angle B is going to be bigger than angle C. Anytime where we're solving for an angle first, like the first angle we're solving for is bigger than the first angle they gave us, we're going to have what's called this ambiguous case. And I'm going to show you guys what that means. So we got that B can equal 40.32 degrees. And if you guys have learned the unit circle, I'm going to draw something up here. This is about 40.32 degrees. You may know that the sine of that angle is the same as the sine of this angle in the second quadrant that has a reference angle of 40.32 degrees. So I'm going to say that again. The sine of this first angle, 40.32 degrees, is going to be the same as the sine of this other angle that I just drew, so this pink one right here, that has a reference angle of 40.32 degrees. So while our calculator told us that the sine inverse of this expression down here, of the 20 sine 15 over 8, is equal to 40.32, we know that it can also be equal to this other pink angle, which is going to be 180 degrees minus 40.32. And if we do that, we get that B can also equal 139.68 degrees. And if you guys want to check, you can type in the sine of 40.32 degrees and the sine of 139.68 degrees, and you will get the same answer when you put that into your calculator. So now what we have to do is solve two triangles. One where our angle B is 40.32 degrees, and one where our angle B is 139.68 degrees. So to save some space on the screen, I'm actually going to go ahead and erase most of this and just keep those two B values, and then we're going to solve both of those triangles. So let's solve the left triangle first. So we're going to solve the triangle when angle B is 40.32 degrees. So what we want to do first is solve for angle A. And we know that the angles in a triangle have to add up to 180 degrees. So to find angle A, we are going to do 180 degrees minus angle C, so minus 15 degrees, and then minus angle B, so minus 40.32 degrees. So I'll just write that underneath. So we're going to do 180 minus 15 minus 40.32 degrees. This is going to be equal to angle A. And if we do that out, we're going to get that angle A is 124.68 degrees. And I'm just going to erase the work down here so we have more space to do the rest of the problem. And now we have to find side A using the law of sines. So we're going to say the sine of angle C over side C is equal to the sine of angle A over side A. We're going to plug in what we know. So the sine of C, we know C is 15 degrees, over side C, which is 8 feet, has to be equal to the sine of angle A, and angle A is 124.68 degrees, over side A. And we are going to cross multiply. So we're going to get A times the sine of 15 is equal to 8 times the sine of 124.68 degrees. And over here, we're going to divide both sides by sine of 15. We're going to get that side A is equal to 8 times the sine of 124.68 degrees over the sine of 15 degrees. And now we're just going to put that in our calculator. And if we put in our calculator, we should get that side A is equal to about 25.42 feet. So for our first triangle, we get that side A is equal to 25.42 feet. Now we're going to have to do the same thing for the second triangle. So I'm going to go ahead and erase all of this so that we have some more space. And we are going to do the same thing for if our angle B is 139.68 degrees. So we're going to find angle A, and we can do that by taking 180 and subtracting angle C and angle B. That's going to equal angle A. And if we do this, we should get that angle A is equal to 25.32 degrees. I'm going to erase this, and now we are going to solve for side A. So down here on the left, we're going to set up a proportion. We're going to say that the sine of angle C over side C equals the sine of angle A over side A. We know angle C is 15 degrees, side C is 8 feet. This is equal to the sine of angle A, which the one we're using is 25.32 degrees, over side A. Over here, we're going to cross multiply. We get A times the sine of 15 equals 8 times the sine of 25.32. Divide both sides by sine of 15 to get that A is equal to the sine of 25.32 over the sine of 15. And now we're just going to put this in our calculator. And we should get that A is roughly 13.22 feet. So I'll write that under here. A is 13.22 feet. So we get two answers for this problem. we get that we could have this triangle with these values for angle B, angle A, and side A, or we could get this second triangle with these values for angle B, angle A, and side A. So just to reiterate, you only need to check for the ambiguous case when the first angle you're solving for, so if the first thing you're solving for is an angle and that angle is bigger than the angle they gave you, then you're going to have to check for the ambiguous case. And the way you're going to do that is you're going to take the angle you got when you solve for your first angle. You're going to do 180 degrees minus that angle. That's going to be the angle for your second triangle, and then you're going to solve both triangles.